Hi. All right, that's it. So, I know everyone's a bit tired. It's been a long day. It's almost tapas time, so I'm going to keep this short and sweet, or I'm going to try to. But before I start, I got to apologize to everyone because this is not really going to be about HomeKit at all. So, when I proposed this talk, my idea was let's build some hardware prototypes, which is what I've been doing for the past 3 years, and then tie them to HomeKit, and then we'll have like a Siri-controlled door buzzer, Siri-controlled like light bulbs, stuff like that. And then I started researching it as more information became available about HomeKit over the last 3 months. It became obvious that Apple has no plans to open this for what they call hobbyists. So you have to basically join the MFI program, which involves questions like, where's your manufacturing plant for your chipset and stuff like that. So it really was out of the question to really dive into HomeKit. So the title of the talk should really be something like this, or what I'm calling Homemade HomeKit. So basically, it's what we end up doing over the last 3 months is build these small projects where they kind of allow you to control like your home or your office, different automations that you can do with simple hardware prototypes using iOS applications. So I'm just going to talk about a few projects. Hopefully, it'll be inspiring and interesting. So I work at a company called Hippo. We have been doing these hack days for the past like 2-3 years, and we basically drop everything and build some side projects for a day and then present them at the end of the day. The only rule is they have to be done during that day. So all of the stuff that I'm going to present today has been done by the team during those days. The theme for the past 3 months for these hack days have been office automation. So just solving different problems that we had at the office through hardware prototyping and interesting software stuff. So let's talk about the projects. We give these funny and weird IKEA-like names to our projects. This one's Dörr. It's I think it's Swedish for door. So basically, the problem that we were trying to solve with this one was the whole office leaves for lunch. Nobody takes their keys. We're locked outside. This actually happened. We were like 18 people. Nobody took their keys. So after this happened, we were thinking, okay, can we solve this through an app that we could just use attach the door buzzer with a simple hardware prototype? And we ended up doing it. So it was pretty interesting. I assume everyone's kind of familiar with Arduino here. Yesterday, there was an Arduino talk as well, so that was great to see. I'm really big on Arduino. I've been hacking on Arduino for 4 years now. I think it's an amazing platform. It was meant for hobbyists, artists, students to build hardware prototypes, so it's really accessible. There's thousands of modules available that you can easily attach to. You don't need to really jump into the hardcore parts of hardware prototyping, and you can really start to build stuff really quickly. So it's pretty exciting. And the basic idea behind Arduino is that you have this Atmega chip inside, in the middle, and you have these digital pins attached to it. So it's actually a very small chipset, but it's kind of blown up out of proportion, so you can see where things are going. You can actually see how things are connected to the CPU. And it's all open source. Like the hardware itself is open source, so you can see the schematics, understand how it works. And it has these digital input and output pins that you can attach other modules to. You can basically burn your own firmware on it. It has a very small storage space where you can burn your software that you write in C or C++. So it's pretty accessible for, if you're an iOS developer, I think it's really easy to get into. One thing about the Arduino is the IDE. The IDE absolutely sucks. It's a cross-platform Java IDE that just doesn't work. But you can use other editors like Sublime Text, for instance, which has amazing modules for Arduino development. So if you do get into it and you're faced with this horrible IDE, don't be scared. Just like jump to some other option. So in this case, for the door buzzer, going back to the project, we basically have this Arduino. And what we're going to use is what's called a relay. a relay is a very simple module that you attach, and it allows you to control a 110 or 240 volt circuit with a 5 volt signal. So the Arduino runs on 5 volts. It sends a very simple signal to this to open or close the circuit, which means that you can basically connect anything in your home or office, like a light bulb that runs on 110 volt in Europe, or 240, or sorry, vice versa, 110 in North America, 240 over here in Europe, and you're able to turn it on and off. You can, control the door buzzer in the same way, because it basically is a very simple circuit that whenever it receives a signal, electricity signal, it will actually open the door, and when it doesn't, it closes. So this was based on that. So once you have this connected, you basically have a system that can open and close, but you have no way of communicating with the Arduino. You can write software on it that just runs on it. So you could, for instance, build something that would open the door every 5 minutes, completely useless, but you could do it. So how do we connect this to, for instance, an iPhone app? That's where Bluetooth LE comes in. So there are these Bluetooth LE chips available, fairly cheap. In this case, we're using Red Bear Lab Bluetooth LE Nano, I believe. They're like $10, $15 chips that are fairly sophisticated. But the nice thing about Bluetooth LE is Apple has been including Bluetooth LE capability into iPhones since the 4S model. So pretty much all the iPhones we have today have Bluetooth LE. So, and the other great thing about Bluetooth LE is you don't need to join the MFI program to build Bluetooth LE apps. So if you were to build a usual Bluetooth app, which is completely unrelated to Bluetooth LE, you would have to join the MFI program, apply to Apple, go through all those processes. With Bluetooth LE, we don't need to do any of this. You can just hack an app on your own, connect to any BLE device, and it's really quick. You don't need to do all the synchronization or pairing stuff that you need to do with other Bluetooth stuff. So it's really exciting technology to work with because it's very refreshing, it's very fast. The only downside to it is that, maybe it's not a downside, is that it has a really low range. So it's like 5 to 10 meters max, depending on where you are, how busy the environment is. So now that we attach this to our Arduino, we have short-range communication wirelessly that can talk to any iPhone app. So we build our app. It can communicate with the BLE chip. What it does is basically sending a very simple signal over the BLE channel. It first connects to it, of course, and then sends the signal, which then is relayed to the Arduino and then sent over to the relay. Now, at this point, you're able to open this app, say, open the door, just tap a button, and then the door buzzes and it opens up. So we already accomplished our goal. So at this point, we just started using this for a few weeks. Everybody started using it, and it was pretty successful. We also built an Android app that we could use. Everyone in the office started using that. We didn't get locked out anymore. It was awesome. But one issue that we ran into was basically you are competing against taking your key out of your pocket. So for instance, you arrive at the office in the morning, you have your keys with you. We want to compete with that experience. Like, how do we make this faster than taking your keys out of your pocket? At that point, one idea was building a very simple today widget, just you can slide down from the top. And we did that. It was pretty good. But then another idea was using an iBeacon. So we just installed an S-Mode iBeacon, the ones you can get fairly cheaply. It's completely unrelated to the setup, so it's just a separate device that you just attach. And it just, you can look up iBeacons if you don't know how they work, but the basic idea is they're constantly sending out broadcasting this signal saying, I'm here. So now we can tie our iPhone app to this iBeacon and say, listen for the signal, and whenever you see it, appear on the home screen, or the lock screen. So whenever you come to the office, you're nearby the office, you just look at your phone, and immediately you see the app's icon in the top bottom left corner, which is it's an awesome experience, because then you can just swipe up on it, the app opens, we detect that you opened it through a beacon signal, so we automatically open the door. And this was the killer feature for us, because the moment we added this, people start using this instead of their keys. So it's pretty awesome to see that. And the final thing, when the Apple Watch came out, we just had to build an Apple Watch app for it. So that's what I usually use. So I'll just show you a quick video. I think we have sound of how this works. So this was shot inside because we have trouble with light, but it's more meaningful when you're coming in from the outside. But you get the idea. Yeah, I mean, as you've seen, it's a pretty quick experience. The Bluetooth connection happens almost instantly, and it connects at that point when you tap the open button. So it's pretty impressive. The Bluetooth LE experience is very impressive in all the apps that I've built. One thing about this is security, right? So it's it's a door buzzer. It literally lets you in the door. So we did need to think about security. Now, in this case, it wasn't so critical, but if you're building a device like this, it is one of the things that you need to consider. So you need some kind of end-to-end encryption because the Bluetooth LE signals can easily be sniffed and easily be spoofed. There are all these apps available on the App Store, like LightBlue, where you can basically detect all the Bluetooth LE devices around you. You can see their identifiers and basically send them custom signals. So it's just a matter of someone finding the right signal to send, and your door's open. So Apple's definitely thinking about this, and I think it's one of the main reasons why why the HomeKit is closed off, because they're requiring all these encryption and decryption requirements from the actual devices. And from what I've read, none of the existing IoT devices on the market are able to support that level of encryption. So, for instance, on an Arduino, you wouldn't be able to match the level of encryption that Apple requires because just the processor cannot support it. So what's happening now, these MFI program members are actually building custom microprocessors that are HomeKit enabled, which are then used to build all these products. And I think that's why we still haven't seen any HomeKit devices on the market. There was one power controller thing that was supposed to come out 2 months ago. Now they're saying it's going to be in October, but there's really nothing that you can play with yet. But the complexity of these security systems, you don't want someone else coming in and using Siri to turn on the lights at your home, super creepy, or just opening your door. So, because a lot will be possible once these devices are available on the market. So that's the door app. The other one is what we're calling Bulb. It's a light control system. We thought our office is like 5 stories. When you're leaving the office, sometimes you need to turn off the lights on all the floors. You need to know if the lights are on or off. It's a bit of a hassle if you're the last person leaving the office. So we thought a remote light control system would be really interesting to build. So this is a project in progress, but I'll show you what we've done so far. Again, we start with an Arduino, but this time we have a bit of a different architecture. This time we need network connectivity, and we also need to be able to remotely control. So we need some kind of server infrastructure to be able to send these messages to multiple Arduinos on different floors, controlling multiple lights from each one of them. So again, we start with a relay. We attach our light bulb this time. Simple setup. Again, you send the 5-volt signal from the Arduino. It either turns on the light or turns it off. So this part is super simple. Again, you can build like a very simple and pointless, blinking lights thing, and it's fun. But the real interesting part comes in when you attach a Wi-Fi or Ethernet shield to this Arduino, and you make it network enabled. Now, when I say shield, just in case you don't know, shields are basically stackable modules that attach on top of the Arduino. So you can stack multiple items on top. It makes prototyping really easy. It's a bit bulky, but it's definitely an easy way to connect things, so you don't have all these cables dangling around. So it literally just stacks on top. In this case, we have an Ethernet shield that just connects to the network. And there are all these network libraries available from Arduino. There are these official libraries that you can use, and they're pretty good. So it's easy to add network connectivity to your Arduino project. And then, in this case, we use a service called Pusher. Pusher app is an interesting service. It is kind of built for IoT projects. It gives you the server infrastructure for free, very quickly set up. And it basically gives you these channels that you can send signals on, and your Arduino or any other IoT devices can register on these channels. So when we have our app sending a signal to Pusher, then all the Arduino devices that are registered and online on those channels will receive those signals. So Pusher acts like a relay that just sends that information over. So again, the idea is we send the signal saying, turn on these lights at the first floor. Pusher relays that message to all the Arduino devices that are registered on that channel. So for instance, you could have a first floor channel on Pusher, and then the app would send it to the correct channel. All the devices on the first floor would be registered, so they would receive that message, and Arduino makes some processing, turns that over to the relay, and then your lights are on. So this is the very simple setup. Now, this project is definitely more complex than the door buzzer because you have to consider network connectivity. For instance, your Arduino could go offline for any reason. There might be an issue in your network. In which case you don't want the lights to turn off. Like if your Arduino is off, your lights should still stay in their existing state, or if they're off, they should go on. So there are all these state handling issues. And then another thing that we ran into was that if you're on the same floor and you just want to turn on the lights, you probably don't want to use an iPhone app. You just want to go there and flip the switch. So we had to build these stateless switches, or buy them and attach them to the Arduino. So all the state goes through the Arduino and is aware of what's going on. So it knows if the lights are on and off, but you can either manually do it or you can do it through the app. It doesn't matter. So some things to consider. It's an interesting challenge when you start thinking about these states. Now, in addition to this, what we kind of want to do was to integrate this with Siri. I mean, the whole point of this HomeKit thing was that I want to control the lights with voice commands. Unfortunately, Siri doesn't have an API yet, so we can't do that. But so we decided to build our own Siri, and we called it Iris. I mean, yeah, nothing else to do, so might as well. Well, we really didn't build our own Siri. We just used OpenEars. It's if you're not aware of it, it's an amazing SDK that does offline speech recognition in iPhone apps. So it's really amazing. It's obviously not as inclusive as Siri. You can't just converse with it, but it does understand a pretty large vocabulary, and you can build these specific commands, create a grammar set, and you're able to get offline speech recognition in your iPhone app. So we integrated OpenEars. The basic configuration looks like this. You have an opening command like "Hey Iris," and you have some initial commands like "Turn lights on," "Turn lights off," and then you have some variables like the first floor, second floor, third floor. This is a very simplistic setup. You can go much more complex than this, and it has some additions like noise canceling that you can purchase, or speech synthesis that you can purchase. So these are all additional modules that you can add on top of OpenEars. But even as is, just the basic SDK is pretty impressive. So yeah, here it is in action. I'll just let you watch.
Hey Iris, turn on all lights. Hey Iris, turn off all lights. Hey Iris, turn lights on at first floor. Hey Iris, turn lights on at second floor. Hey Iris, turn off all lights.
So you get the idea. Thanks. So yeah, it's pretty cool. It's pretty impressive what you can do. Like, this is just a 2-day hack that we put together. That's just a test bed. But this is actually now, it is actually integrated into one of the floors. into the actual lights in the ceiling. So it's really fun to be able to do that. One thing to consider about this is background mode. So this actually works in background. Like if your phone is locked, it will still be listening and it will understand you. It's just pretty impressive. But unfortunately, background mode microphone usage gives you that red bar. So it's really not that useful, or it's kind of intrusive. So we don't really have it turned on at all times. You have to kind of launch the app and have it listen. But we are working on a watch app that will probably work pretty well, and also again a today widget that could do that. So yeah, there are ways of getting around this limitation. So to conclude, you can't play with HomeKit yet. At least, I mean, you can, but all you can do is play with the simulator that comes with Xcode and kind of simulate the devices and then build apps that talk to those devices. But if you're interested in hardware prototyping, it really doesn't make much sense. But you can build your own hardware, and I think it's really fun, challenging, and very rewarding when you're able to accomplish these things. I think it's a really good practice for software developers to get into hardware, because our day-to-day job is on these very limited but also very powerful machines. And building on a platform like Arduino, you have a really good a lot of respect for what the iPhone can do, and also you have a really good understanding of processing limitations, memory limitations, network condition issues, and I find that it really feeds into my software practice. So pretty much everything that I talked about today is open source, available on GitHub. Feel free to check it out. All the Arduino sketches, everything is online. If you still would like to learn about HomeKit, Apple has 2 really good sessions from the 2 years of WWDC, the last 2 years, and they basically get into every detail that you can think of. And it is pretty impressive how wide-ranging the API is and all the things that you can do with it once the devices become available. That's it. Any questions?
Great talk. You mentioned something about security. I'm not entirely sure I got a resolve on what you guys did to basically get around the whole Bluetooth, well, lack of security around the Bluetooth protocol. What did you guys do?
I'm not telling. Yeah, it's very, very rudimentary and almost laughable what we did. Like, it's basically you have a passkey that changes on a daily basis. And that's encrypted on both sides. So you have a private key that changes, a private key that's embedded, and a public key that changes. But that's not security. Like, that's not secure at all. And you could just basically sniff that message during the day and sometimes figure out a way in. So it's definitely not a solution. So that's why I didn't really get into it. I'm sure there are people who know about that a lot better than I do. But yeah, I mean, the team had quite a few ideas about how to go around that. But to be honest, it's not a huge issue for us, so we didn't really focus on it that much.
Great hacking, first of all.
Thanks.
I like it. Have you played with any of the HomeKit bridges that came out recently? I saw a couple of projects that allow you to emulate HomeKit devices running on Node.js, or the other one is written in Go, I think.
Yeah, I didn't play with those specifically, but if you want to play with HomeKit, Apple has a great device simulator that you can use, and you can simulate bridges or you can simulate actual devices.
What I mean is, I think what I saw is this is a platform that allows you to connect you'd connect the Arduino and presume that it's a HomeKit device, and it would work. Like iOS would assume that it's a HomeKit device.
No, I haven't had the chance to play with it. To be honest, I'm not even sure. Like, you can probably maybe do something through Xcode, but I really doubt you can connect an actual Arduino directly to HomeKit. But maybe through that bridge, it does all the encryption stuff that's that's required, and now you're able to talk to other devices. I'm not sure.
Thanks.
Very cool. I'm curious on the watch integration. Did you use watchOS 2, and was it able to connect directly from the watch using Bluetooth, or did it bounce to the extension?
No, we didn't use watchOS 2. We tried connecting directly from watchOS 1. It just didn't work. It would work, but it would just fail to connect. Like we weren't able to establish a solid Bluetooth LE connection. So we just went through the app, and then it was great. Yeah. So. I think, from my experience, relying on the watch I don't think it makes sense, because I think the Bluetooth LE signal is much weaker. So yeah.
That makes sense. Do you know what the latency is roughly, like going from the watch through the phone versus just using the phone directly?
I don't have numbers, but I have never seen it go like it's almost instant. Like the video is an actual demo. Like you just tap and we actually have that Mario team playing. If we didn't have that, it would be instantly opening. So yeah.
That's awesome. Thanks.
I think that's it. If you have any questions, please feel free to email me, DM me. I love talking shop about hardware or software. So yeah, thank you.